Good morning. My name is Azra, and today my topic for presentation is memory hierarchy. So, first we'll see what is memory. The memory unit is an essential component in any digital computer since it is needed for storing programs and data. A very small computer with limited application may be able to fulfill its intent task without the need of additional storage capacity. The most general purpose computers would run efficiently if they were equipped with additional storage beyond the capacity of the main memory. Now we'll see the types of memory. So basically, we have two types of memory, which is main memory and auxiliary memory. Main memory stores the instructions and data which are used during the program execution, whereas auxiliary memory holds the programs that are not currently in use and which is a long-term memory. So now what is memory hierarchy? So memory hierarchy is an enhancement to organize the memory such that it can minimize the access time. The memory hierarchy was based on a program behavior as a locality of references. So this is the photo of memory hierarchy, which shows the first is registers, followed by cache memory, then main memory, then flash disk, traditional disk, and remote secondary storage, that is internet. So this is that hierarchy. Now, this memory hierarchy is basically divided into two main types, which is external memory and second one is internal memory or say primary memory. So external memory, which is also called secondary memory, comprises of magnetic disk, optical disk, magnetic tape, that is peripheral storage devices which can be accessible by the processor via module. So these are the external memory which we can buy and attach to our cpu whenever we run out of storage. So yes, they are external memory, whereas internal memory is the part of CPU which is inbuilt in our CPU and comprises of main memory, cache memory, and CPU registers. This is directly assembled by the company in processors. Yes. Now we'll see how this hierarchy is divided into. So typically, like if we'll see the diagram, we'll see there are six levels, but when we generalize them, there are only four kinds of memory allocated in this memory hierarchy. So first one, as we say, is registers. Second one is cache memory. Third one is main memory, and from fourth onwards, that is fourth, fifth, and sixth, is a secondary storage. So flash disk, traditional disk, and remote secondary storage are part of secondary storage. And we saw what secondary storage is. They can be installed externally to CPU for our extra needs, which our computer cannot provide. Okay. So we'll see all these individually. So registers are small high-speed memory units located in the CPU. They are used to store most frequent data that uses data and instructions. So registers, when the operation is being performed, the data and instruction which are required in all this process, they are stored in the registers. It has the fastest access time and smaller storage capacity, typically ranging from 16 to 14 bits. Sorry. Then cache memory. Cache memory is a small, fast memory unit located close to the CPU. It stores frequently used data and instructions that have been accessed from the main memory. So when the program is being executed, the last instruction and the codes that were used is stored in the cache memory. So whenever the program needs the previous programs or executions data, then cache memory provides it. Now we will see main memory. So main memory is also known as RAM, which is random access memory. It is a primary memory of a computer system. It has a larger storage capacity than cache memory but is slower. Main memory is used to store data and instructions that are currently used in the computer. So if we talk about the capacity of main memory and cache memory, main memory can hold much more data than cache memory, and obviously it will be slower because it has much more to store. Then main memory stores the instructions and data that are currently in use by the CPU. Okay, so now we'll see secondary memory. Secondary storage memory such as hard disk drives and solid state drives is a non-volatile memory unit that is a higher storage capacity than main memory. It is used to store data and instructions that are not currently in use by the CPU. So secondary memory stores extra is an which we previously discussed is is external data, and it stores the external data is an instruction that are not used by CPU, and it is kinds of permanent kinds, like unless we delete it, it will remain in that. Then the characteristics of memory hierarchy design. So this means what we come to know from seeing memory hierarchy design, like what it denotes. It could be a triangle, a rectangle, but why is it triangle? So what it denotes. So first is capacity. So, in the global volume of information the memory can store, as we move from top to bottom in the hierarchy, the capacity increases. So, from higher to lower, when we come, that is from register to secondary data, the capacity of them storing the data increases. That we seen in previous slides. Then talking about access time, as you move from top to bottom, the access time also increases. That is the memory process, memory fetching, the data fetching process by the memories slower by time. uh, yes, this is it. Then performance, and performance, as we go from top to down, the so as we go from top to down, the performance lowers, because as they store much data, it becomes difficult for them to retrieve data. So performance obviously decreases. And the last one is cost per bit. This is a financial factor. So as we go from top to bottom, the price decreases, or we can say as we go from uh, bottom to top, the price decreases. Bottom to top, the price increases, as we can say that price obviously depends upon how the thing we are purchasing is working. So as we go from bottom to top, the efficiency of memory increases, so obviously the price would increase. So this is about the memory hierarchy, their characteristics, their individual memory, what they do, what things they store. So this is about memory hierarchy. Thank you so much.